Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we will discuss about model question paper questions. The topic is lubricants module. So how to attempt the questions in the examination we will see in this session. So already we have discussed about engineering tribology modules. So theory part already we have covered in the module 3 in lubricants. So now the detailed question paper, how they will ask questions in examination, we will see one by one. So model paper 1 questions and answers. So we explain the term lubricant and their physical properties. So he has asked a question, explain the term lubricant. What do you mean by term lubricant and their physical properties? So a lubricant is a substance used to reduce friction and wear between surfaces in mutual contact. So whenever the two surfaces are in contact, so there is a wear and there is a friction. So to minimize this friction, you have to use some medium that is lubricant in between the surfaces. So which ultimately improves the efficiency and longevity of missions. That is the lifespan. You can improve the lifespan of the missions and mechanical components. So lubricants can be in the form of liquids, solids, or gases. The most common lubricants are oils and greases. So here the common lubricants shown given oils and greases are common lubricants. So what are the physical properties of lubricants? So the main properties you should remember while selecting the lubricant. One is viscosity. So the definition is viscosity is the measure of a fluid's resistance to flow. So it indicates how thick or thin a lubricant is. So the importance of this lubricant film, it affects the viscosity, it affects the formation of the lubricant film. So high viscosity provides better film strength, but too high can cause increased resistance and energy loss. Low viscosity ensures easy flow, but may not maintain an adequate film under high pressure. Next, viscosity index. You can write represent with VI. So the definition is viscosity index is a measure of the change in viscosity with temperature. The importance is a high viscosity index indicates the lubricant maintains consistent viscosity across a wide temperature range, which is desirable for performance stability. And density and specific gravity. So definition is the density is the mass per unit volume of the lubricant, and the specific gravity is the ratio of the density of the lubricant to the density of water. So the importance is these properties affect the flow characteristics and the lubrication process. Particularly in hydrodynamic lubrication, you can see this importance of this density and specific gravity of lubricant. Next property is 4 point. So the lowest temperature at which a lubricant remains fluid, so that point is called as 4 point. The importance is it indicates the usability of the lubricant in cold conditions. So next flashpoint definition is the lowest temperature at which the lubricant vapors ignite when exposed to an ignition source. The importance is it provides information about the lubricant's volatility and flammability, indicating safety limits during storage and use. So this is the importance of these lubricants. So next fire point, the temperature at which the lubricant ignites and continues to burn for at least 5 seconds. So that point is called as fire point. The importance is it is crucial for understanding the lubricant's behavior in high temperature applications and for ensuring fire safety. Next point is thermal stability property. Next property, thermal stability, the definition is the ability of a lubricant to resist chemical decomposition at elevated temperature. The importance of thermal stability is it affects the lubricant's longevity, that is lubricant's lifespan, and effectiveness in high temperature environments. The oxidation stability, the definition is the ability of a lubricant to resist oxidation, which leads to the formation of acids, sludge, and varnish. The importance is high oxidation stability ensures longer service life and consistent performance of the lubricant. The corrosion protection, the ability of a lubricant to protect metal surfaces from corrosive environments. The importance is essential for preventing rust and corrosion, thus extending the lifespan of mechanical components. So next property is additive compatibility. As per definition, the ability of a lubricant to work effectively with added chemical compounds that enhance its performance. Anti-wear agents, detergents, dispersions. So importance is ensures that additives provide intended benefits without adverse reactions. Next, the difference between elastode and plastode aerodynamic lubrication with suitable examples. So, what is the difference between these two lubrication systems, elasto and plasto aerodynamic lubrication? So, elasto aerodynamic lubrication, that is EHL, occurs when the lubricant film is capable of supporting high loads due to elastic deformation of the contacting surfaces and increased viscosity of the lubricant under pressure. Characteristics are one is elastic deformation, high pressure, thin film, and low wear. So the surfaces in contact experience elastic deformation under high pressure, creating a thicker lubricant film. So the pressure is high enough to increase the viscosity of the lubricant significantly, but not so high as to cause plastic deformation. Thin film, despite the high load, The film thickness is usually in the micro to nanometer range. The elastic deformation helps maintain a continuous lubricant film, reducing direct contact and wear between surfaces. Examples: rolling element bearings. In ball or roller bearings, the high pressures at the contact points between rolling elements and races lead to the elasto-hydro lubrication conditions. So next example is gear teeth. In gear meshing, the contact points between the gear teeth experience high pressures leading to elasto-hydro lubrication. So elasto-hydrodynamic lubrication occurs when the lubricant film is capable of supporting high loads. So due to elastic deformation. So example, the rolling element bearings, it can withstand the high loads, high pressures at the contact points. So that's why the races, inner races lead to elasto-hydro lubrication conditions. In gear teeth also same property. Contact points between gear teeth experience high pressures leading to EHL. Next one is plasto-hydrodynamic lubrication, PHL. As per definition, the plasto-hydrodynamic lubrication occurs when the pressures are so high that the surfaces in contact undergo plastic deformation, along with significant changes in the lubricant's properties. So whenever the pressures are so high, so that the surfaces in contact so undergo plastic deformation. This type of property, plasto-hydrodynamic lubrication property. Next, characteristics. Plastic deformation. The surfaces in contact experience permanent plastic deformation due to extremely high pressure. The extremely high pressure means the pressure is sufficient to cause both plastic deformation of the surfaces and significant changes in the lubricant's flow behavior. Significant film changes. The lubricant film may be thicker than in EHL due to plastic deformation, creating a larger contact area. High wear. The plastic deformation can lead to more significant wear compared to the CHL, elasto-hydro lubrication. Examples for this lubrication system: metal forming. Process like extrusion, forging, deep drawing. These all are mechanical machining processes, manufacturing process comes under the metal forming, where the pressures are extremely high and the metal surfaces undergo plastic deformation. Heavy load bearing. In applications like a heavy duty industrial process or large gear systems where the loads are so high that they cause plastic deformation of the contact surfaces. Key differences, the major differences between this elasto-hydrodynamic lubrication and plastic deformation of the surfaces, EHL and PHL, the pressure levels are HL, high pressure that increases lubricant viscosity but not enough to cause plastic deformation. The PHL is extremely high pressure that causes plastic deformation of the surfaces. So next, wear and surface damage. In the case of EHL, generally results in lower wear due to maintained lubrication film. In PHL, higher wear due to plastic deformation and potential surface damage. So these are the references I have taken for this question bank, model question bank. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.